This is a tutorial on simple phase estimation. Phase estimation simply means the value of phase in the eigenvalue. We will be doing it on Google Colab. And for that we need to install Bluecat. We can install Bluecat by a code, !pip install Bluecat. Don't forget to type the exclamation mark in the beginning. Now let's try on Google Colab. Type in the code that was shown earlier. After typing the code, click on play button. It will take time to install Bluecat in Google Colab. Phase estimation consists of two main parts. First one is controlled unitary part. Second one is inverse Fourier transform. To go on with next step. That is initiate, create circuit and run. Firstly we will import a Bluecat module by typing the following code. From Bluecat import circuit. We have also seen this in earlier video on Bluecat. After that, we can create a circuit by the following code. Now to give brief explanation about the code. This circuit uses 2 qubits. Control gate is in state 0. And input is on second qubit. In the end of the quantum circuit, the qubit will store the estimate of phase. It also apply Hadamard gate on control qubit for superposition. Then, it will apply control gate equivalent to unitary operator. Here, we will get the phase of X gate. The eigenvalue will be 1. And phase will be 0. After that, for the final result and to get a bit, the code will perform inverse Fourier transform by the H gate. The final result of this will be 0 and phase will be 0. Now let's try it on Google Colab. Type in from Bluecat import circuit and after that type in the code that was shown earlier. After the completion of code, click on play button. Final answer is 0, 0. In the next code, we are going to add a ZAT gate to the earlier circuit code. So, for this code we have X as given. We will get eigenvector as given below. And eigenvalue as -1. So, we will get first bit as 1, and phase as 0.5. Now, let's try it on Google Colab. Type in the code that was shown earlier with a ZAT gate. After completion of the code, click on play button. Thank you.